is Special Investigator Nathan Builds Robots, here with another 3D printer review. I've collected some damning evidence that points to Creality's incompetence in design and backwards engineering practices. Each one of these pictures is a crime against mechanical design. These are just really bad design decisions. Let's start with this. Which one of these extruders looks better to you? Do you think this one looks better? It's just a bunch of laser-etched markings on the back of a stepper motor. Or do you think this one looks better? We've got these nice heatsink fins on the front here with an attractive little Creality marking, some little branding there. I'd say this looks a lot better than this. But on the Sprite Hotend, this is what you see when you look at your printer. When you put the fan shroud on, it covers up that beautifully designed facade there. So why is this all covered up? This is the best looking part of the Hotend. So what I put here is that the extruder has a nice behind. If you look at the back of the extruder, it looks really good. But if you look at the front of the printer, it's butt ugly. Let's keep thinking about this. If you look at the Hotend heatsink here, the odd thing about these fins is they're completely covered up by this fan shroud. None of the air goes through those fins. So that doesn't make any sense. Why would you put fins here if you're not going to get any airflow because it's just covered up by this plastic part? Then we look at some other silly stuff. You can't see anything that it's printing. You've got this big stepper motor in the way that's blocking a lot of your view. You've also got a fan shroud that blocks the rest of your view. And you just have like basically no visibility to what you're actually printing. And I think that people really like to see what's going on when they're printing an object. It's just really fun to watch the printer work, you know, watching it zip around and lay down plastic. But there's also a practical reason for you to be able to see what's being printed. If your print is starting to fail, being able to see that as soon as possible is very important. And when you're covering up most of your view of the Hotend and the nozzle, you can't see if your printer is having issues. And that brings me to the other odd thing about print visibility. If you turn the printer around, you rotate it 180 degrees and look at it from behind, there's no obstructions and you have a great view of what's being printed. So that got me thinking, why don't we just take the Sprite Hotend, flip it 180 degrees, and that way you can see this awesome branding that they put on the front. You have easy access to all of the screws required to disassemble the printer and service it, and you have great visibility to the Hotend and nozzle so you can see how your print is doing. Now if you're trying to imagine what this would look like in practice, you don't have to try very hard because I've got one right here that's set up just like that. Let's take a look at the printer. The world's first and only Sprite Hotend that's installed the right way around. I've designed a whole fan shroud around this concept and I'm using my motherboard to facilitate the connections. Now I just need to install the actual Hotend here. Everything from the heat breakdown is missing. I just need to pop something in there. That looks great. I'm really excited to fire this up and see how it works. I'm going to get rid of this polycarbonate print surface and I'm going to replace it with this PEI sheet. Alright, so we've verified that our Hotend fan is working, the heater and thermistor and BL Touch is wired up correctly. Overall the print quality is looking pretty good. My bed leveling's working. I mean, this is a great first test. One of the things that you'll notice right away with this upgraded Hotend is I can see everything that's going on with the print area. I really like being able to see what's going on with the printer. It just makes it a whole lot more fun to watch this thing work. The other thing that I made sure to do with this fan design, I wanted to get the ducts out of there, push them off to the side so that I can see everything. I mean, sure, you might get marginally better part cooling if you get ducts that lead right up to the nozzle tip, but I like being able to see stuff, and this provides a lot better broad cooling action, and you get a whole lot more airflow since these ducts are wide and unconstricting. Despite being sliced for the wrong diameter nozzle, this print turned out really well. I got another model from Mandic Really on Thangs, so I'll be printing out some bananas. This print should take about 4 hours and 20 minutes. I really like how I can just see everything that's going on with this printer. I enabled Z-hops on retractions, and you can see whenever the print head picks up, it leaves behind some really bad stringing. When this part cooling fan is in the area, it's just making that stuff go crazy. It's getting blown all over the place like it's in a tornado. One of the secrets of this duct is I'm minimizing the amount of ducting that it needs to flow through. It's basically just directly outputting the air from the fan and shaping it into an air blade that's blowing right into the area where things are printing. Normally I make a big deal about fan noise and, the fan noise, I gotta get rid of it. On this machine it is loud, but I'm getting performance for that noise. In terms of overhang performance, this is like unheard of to get this good of overhangs with a 1.1 millimeter wide extrusion width. On a lot of my other large extrusion printer builds, I really stay away from doing any type of overhang just because it doesn't do that good of a job at printing them. So pretty good results so far. I'm pretty happy with how this is working, and we'll just keep printing with it. There's a lot of contributing factors that make part cooling more difficult on thick extrusion prints like this. First, you're putting out really high volumetric flow rates. But on top of that, when you have a layer of filament that you're laying down and you're moving the print head slowly, it doesn't have a whole lot of surface area compared to a 0.4 millimeter nozzle moving much faster. You'll have a much longer line with much more surface area when you're using thinner extrusions. So part cooling is inherently easier with smaller nozzles. Also, the heat has to travel further to escape the center core of that filament that's been laid down. Basically, when you lay it down, you can assume that it's all a constant temperature of about 200 degrees Celsius, and the outside cools off first, but the inside stays molten a little bit longer. And that heat has to slowly escape by traveling through the plastic, getting to the surface, and then being blown away by these fans. So that's yet another factor making it more difficult for these parts to get cooled down. All of that adds up to a printing experience that requires much better part cooling to get the same levels of overhangs. So the fact that I'm able to go over 45 degrees with this big of a nozzle is actually really surprising to me, and it makes me wonder what this fan shroud would be capable of on a 0.4 millimeter nozzle printer. The next thing I want to do is check out this part cooling fan. What I like to do to help visualize the flow of the water is just grind some pepper on top. Pepper floats on the surface of water really well, so it's a nice material to help you visualize what's going on at the water's surface. I just cranked up the frame rate to 60 frames per second, so now you can see everything that's going on the surface of this water. So we'll turn the fans on all the way. Pardon the noise, they're a little bit loud. We're about 65 millimeters away from the nozzle, and you can see it's already moving the water. Now we're a little over 40 millimeters away. Now we're about 15 millimeters away. I'm going to add a little bit more pepper so we can see what's going on here. There's like this vertical blade of air. It's kind of cutting a channel through the water. It's like Moses parting the Red Sea or whatever. It's definitely got a ton of airflow going. We're about 15 millimeters away right now. Let's move it down to, let's say, 5 millimeters away. And you can clearly see there's this gigantic void under the nozzle. I mean, if you look over here towards the fan ducts, it looks like we're only about 4 millimeters away from the surface of the water. But if you look over at the nozzle, we've got a full centimeter between the water and the nozzle because it's just got so much air pressure that it's displacing that water. I'm going to keep moving it down so the fan duct is about 1 millimeter above the water's surface. The hot end is not touching the water at all. I'm going to go ahead and submerge it a little bit and see what happens. Just, I don't know, for science. I don't want to ruin the BL Touch. This is a bad idea. And just out of curiosity, I'm going to turn the fans down to about half strength, and we'll see how it does. I mean, it still looks like it's providing a good amount of part cooling. Alright, now we're setting up like a really nice flow pattern here. I want to get a close-up of that. When two fans are blowing at each other, it meets in the middle and it gets shot out to the side. So we need more pepper. But do you see that flow pattern? It's very symmetric. This is such a good visualization of this kind of flow. This is very entertaining. Alright, I'm getting pepper all over the place. I think I need to stop. These fans are designed to induct air, just like that Dyson bladeless technology. Pretty much any good fan shroud design is going to have the air flowing along the outer edge and just kind of amplifying the volumetric flow of air. That's just free cooling performance. The other trick with this fan shroud is that I'm not messing around by having ducts leading all over the place and constricting the air down into a tiny little channel. You want the air to be as free as possible, and ideally when I'm designing these things, I like to have the air just be going a straight shot through the duct and just flattening it into a blade, because that generally gives you the best spread of airflow. A good rule of thumb is to maintain the same cross-sectional area of the outlet of your duct as the outlet of the 50-15 blower fan. Because if you're narrowing it down a bunch, sure, you're able to build up more air pressure, but you're losing a ton of volumetric flow of air. When you're printing big, thick parts like this, you just want to blast everything and get it all cooled down as fast as possible. Anyways, I mean, I could nerd out about this forever, but I think I've got to get back to printing, and we're going to have to move on with things. Okay, that's been enough fun for today. Oh yeah, that's spicy. Seeing that nice visualization of the airflow that's coming off of this hot end gives me a much better appreciation for the aerodynamics at work here. I can definitely feel that there's like a vertical blade that runs along the y-axis. It's just blanketing this whole area with a ton of cooling air. Now I'm going to clean this up with a torch. And just like that, this part is looking a lot better. Still not perfect, but this model really wasn't designed to be printed on a printer like this. This is another model that I printed. You can see there's some pretty steep overhangs here, and the printer handled it very well. Ow, ooh, that's hot. Well, anyways, now that I've cleaned up that stringing, this model's looking a lot better. And you can see it's just got really good details in here. It handled those overhangs very well. So out of all the wide extrusion printers that I've built so far, this one definitely has the best part cooling, and it's the most capable of printing any generic object. This cup model here has some pretty steep overhangs, but I don't really have to worry about it on this printer because it's got such good part cooling. I printed out this bridging and overhang test. I didn't do any tuning, I just kind of threw this on here and went with it, and it turned out pretty good, all things considered. And it was able to print successfully all the way up to 70 degrees. I might even be able to reach 75 or 80 degree overhangs with this printer. You can see it's got the overhang angles printed there. It doesn't show up very well. Here's my little retraction towers. Not the best performance there, and the slicer was kind of freaking out a little bit. It actually skipped a couple of the layers on this tower for some reason. So the Sprite Hotend design is kind of a mess, and it has a seemingly confused design language. I think they originally planned for this side of the Hotend to be facing forwards, and there's a lot of evidence to support that theory. They put a lot of thoughtful design details into what I'm calling the true front of the Hotend. They've got this nice logo, they've got these exposed heatsink fins, and with this side forward, you have perfect access to all of the important fasteners for disassembling the extruder, and a lot of people have trouble clearing jams on this machine because you have to remove the hot end from the printer, take this back plate off, take this little fan off, take the plate that the fan attaches to off, undo these two screws, and pry this apart. That's a ton of steps to be able to do a relatively basic maintenance task, which is really common to have to do, especially if you're printing flexible filaments that like to get tangled and jammed up in there. But if you just install it with the true front forward, it's really easy to take the extruder apart. You just undo these two screws and you can just pull that whole front plate off. You have access to all the gears, and this thing would just be a dream to be able to service and repair. But that's not what we got. Instead, they decided to flip this extruder around and have the stepper motor facing forwards and put all of these nice looking pieces, all of the important fasteners for assembly and maintenance, all those get tucked away into the back of the hot end. Additionally, by flipping this around, you've completely destroyed all visibility that you had of the print head. All you can look at is a big ugly fan duct or the stepper motor, and that's a huge detriment to the user experience. And then you've got the matter of this breakout board. What's going on with this breakout board? Why is it shaped so funny? Why is it tucked away in the back where it's hard to access all of the important connectors? Really, you want to have that stuff be accessible so that if you need to do any maintenance or repairs, you can just unplug something, test it out, plug it back in. It's just a really hideous design. Everything gets kind of congealed into this poorly designed mass, and the thing becomes completely unmoddable. Now I want you to think about that. This thing becomes completely unmoddable. The Ender 3 series used to be kind of the sweetheart of the 3D printer market because you could buy it, pull parts off of it, upgrade it, throw new stuff onto it, and just make it the machine that you really want it to be. So that's what I'm trying to bring back with this Ender 3S1 modder board. It's a drop-in replacement, and it gives you all of the old style ports that allow you to have a plug-and-play experience when it comes to modding your Ender 3. Testing for this new board design went well, so I'm pleased to announce that the next edition of the board will be coming out. So if you head over to my website, nathansellsrobots.com, you can put in a pre-order for one of these boards. I hand-built all of these first edition boards. It was a lot of fun, but it was also a lot of work, and I don't think it's sustainable for me to do long-term. So the next batch of boards is going to be made by a third-party manufacturer. I'll still be inspecting each board and testing it with Mr. Clicky here. I brought him back to life for this next revision of boards. The new boards are constructed using lead-free components and materials, and I'll be able to sell them internationally. I added some new functional features to the board as well. I was able to locate a source for these little latching connectors. Also, I added an additional fan port and a place that you can add a voltage dropping device. So this will allow you to install 12-volt Noctua fans. There's going to be a little bit of how-to on how to do that because I didn't want to just include all of that pre-assembled on the board. It's not about cost, it's more about safety and managing the thermal buildup that might occur. It's really not too complicated, but I just wanted to make sure that you have a good understanding of how everything works before you plug in a 12-volt fan that draws too much current and potentially fries the board. But anyways, back to my Sprite Hotend theory. I think they originally planned to install it with this side forward because everything kind of points to that being the most logical solution. But at the last minute, they had to figure out how to attach this breakout board to it, and I guess they couldn't really figure out a way to do it that made sense. So they were like, okay, well, let's just print out a little plastic fan shroud or something and stick the breakout board on that and then attach it to this thing. There is one advantage to having the extruder as close to the X gantry as possible, and that's that it cuts down the amount of leverage that the nozzle has over the whole gantry. So if you bring the nozzle in as close as possible, the printer has a lot of control over it, and if it runs into any bumps, it's able to overpower it a lot easier. versus the way that I have it set up here. The actual nozzle is about 2.5 inches away from the x-axis profile. So that's like having the nozzle out here and it's trying to print stuff. And if it runs into any bumps, it might kind of get pushed out of the way a little more easily. At the end of the day, design is all about compromise and finding a good solution that works, and this is what they went with. Personally, I think it works a lot better like this. Just the things that I value in 3D printing, which are good serviceability, fun to use, good visibility, good part cooling, modability, all of that. I think this kind of setup delivers much better on those fronts. The last thing I want to touch on is that I still don't quite understand why Creality went with this breakout board design. It's really not very good, and it's something where if you're mass producing a printer, you really should be thinking these things out a little bit better before you release the product. They're using this right angle JST plug for the hot end heater cartridge, and when you're plugging in the wires for the heater cartridge, they're pretty stiff and they'll kind of bend this around. And I've heard of cases of these parts getting damaged just from the strain of it being installed. Also, this little thermistor connector is not good either because it's right up against the heater block. So yeah, not so great. On my breakout board, I've actually recessed this thermistor connector there. So even if you're using this as a drop-in replacement, you can still use all the original equipment. But I've recessed it a little bit just to give it a little bit of extra strength and get it away from the heater block a bit. So I'm just trying to do my best to improve this design and give people the user experience that they kind of expected getting into the Ender 3 lineup. Having all these standardized connectors makes modding a lot easier and a lot more fun, so I think it's something that we can all get behind. I'll be releasing the CAD files for this backwards fan setup on my Patreon, but you won't be able to do it unless you come up with some way to redo a bunch of the wiring on this thing. And that's only really possible with this breakout board. Oh, also, this is the Ender 3S1 Plus. It's about what you'd expect for an Ender 3S1. It's kind of the same thing as the Ender 3S1, it's just bigger. One of the things that I did to make sure that this hot end is as strong as possible was to tighten up the bolts leading to these Delrin wheels. I'm going to do a deep dive on the construction of these Delrin wheels in a video where I compare these wheels and metal wheels and linear bearings and linear rails. But for now, all you need to know is you might need to tighten these wheels up a little bit to get the best performance. Basically, it's two bearings side by side, and by tightening that bolt together, you're introducing some axial preload, and that's going to cinch those bearings up instead of just kind of being loose and wobbly. If this was just a single bearing, this thing would be super wobbly because these types of bearings usually have a little bit of play built into them. But when you've got two bearings and you cinch them together, that kind of forces it to behave a lot better for this kind of application. It's kind of like a poor man's roller taper bearing. The last thing I want to talk about when it comes to these questionable design decisions by Creality is the possibility that they might be doing this to bake in a level of designed obsolescence. Designed obsolescence is a term that's thrown around in product design all the time. Basically, if you make a washing machine that lasts 100 years and never breaks down, you're not going to sell that many washing machines because you'll sell it once and you'll never get any repeat customers. The same can be said for cars and refrigerators and all these other expensive devices. If they're super reliable, built like a tank, last forever, really easy to service, then people won't be buying them over and over again. So a lot of times in product design, you'll want to bake in some weak point into the product where eventually it'll wear out, and then you basically just have to throw the whole thing away and get a new one. I think you could make a pretty strong argument that Creality added this breakout board to add in a layer of designed obsolescence for the Ender 3S1. The whole idea behind having a breakout board is it makes things easier to plug in, change around, and service, but the function of this breakout board seems to be to lock you into an ecosystem where you just have to use these tiny connectors and find specialized components that plug into this crap. And guess who sells the components that are compatible with this ecosystem? Creality! Is it Creality? Yes, it's Creality. They're the ones that are selling the stuff that you'll have to buy to replace parts on your printer. If you look on my breakout board, I've included all these old school standardized connectors, so there's a huge amount of third-party options to be able to replace components on your printer. I think one of the most heinous examples of designed obsolescence on this printer is the stepper motor. It's got a special 4-pin connector that nobody else uses for stepper motors, and it's got these tapped holes in the sides that nobody in their right mind would put on a stepper motor. It's like they just kind of drilled and tapped some random holes onto the side of a stepper motor, which is supposed to be a standardized component. We've got the NEMA 17 standard that dictates all sorts of dimensions that make stepper motors easily replaceable. But Creality decided to add a bunch of features on here that mean if your stepper motor goes out, you have to buy a new one from Creality. If you want to upgrade to a nicer stepper motor, well, you can't really, because it's not going to have this stupid plug and it's not going to have these stupid holes on it. Also, these hot end and thermistor connections I think are just kind of dumb. I don't like them. I mean, sure, technically they're fine. This type of JST connector is rated for between 2 and 3 amps typically, which sounds okay because a 50-watt heater cartridge at 24 volts is only going to be drawing a little over 2 amps. But when I design things, I build in a huge margin of safety for everything because it provides just that, a margin of safety. So if anything goes wrong, you're not going to have your printer catch on fire. Say something gets installed incorrectly or something's drawing more current than it should. Your device is just tough enough to handle that abuse, and you'll get through it and people will be able to use it just like there's nothing wrong with it at all. And the other thing about this is they actually wired these fans up backwards from what everybody else is doing. So they either did this insidiously so that you have to buy replacement fans and stuff from Creality, or they're just incompetent and they flipped the wires around and they didn't bother correcting it in their PCB design. That's something that's happened to me multiple times when I was designing this PCB. I'd get the polarity of a connector switched around, so I'm like, ah crap, I got it wrong, let me go and fix it. And then on the next batch that I order, everything will be flipped the right way around and everything's going to be good. That's what a responsible engineer would do. But instead, what Creality did is they doubled down and made a whole supply chain of backwards wired fans to accommodate this stupid board. I mean, it's just silly. So anyways, I hope you don't take this video too seriously. I've had a lot of fun making it. I don't really fancy myself as a detective or anything. I don't think a string board is the most effective way to get to the bottom of a situation, but it certainly adds a nice dramatic effect. I'd like to hear your thoughts in the comments below of what you think about my theory about the Sprite Hotend being backwards. The more that I think about it, the more that I think it's definitely true, but that's probably just the confirmation bias kicking in. Alright, thanks for watching this episode of Nathan Builds Robots. Remember to like and subscribe, and I'll see you in the next video.